afternoon, or good morning when you're online, or good evening. It's my great pleasure to welcome you to this seminar in part of the series of the Department of Epidemiology of the Harvard Medical School. My name is Bert Hoffman, I'm the chair of epidemiology, and it's my great pleasure also to introduce Dr. David Hunter. Because for most of us here, need no introduction, but I will tell first that he is an emeritus professor here in our institution, the Vincent Gregory Professor of Cancer Prevention. He's also Richard Dole Professor of Epidemiology, and that to me, whatever it means, is a very, very high title in Oxford. Also in the Broad Institute of Harvard and MIT. Founder of the Genetic Epidemiology program in the Department of Epidemiology, worked in many, many areas, particularly in cancer, and will speak now about work done mainly in Oxford related to dementia. Great pleasure to have you. I'll give you the floor, and thank you for being with us, David.
Thank you. Fantastic. Can you hear me? Great. Fantastic. Great pleasure to be back. Always good to be here at the school. And I'm going to talk about some recent results on the epidemiology of dementia. So when I got the date, I thought maybe someone was pulling my leg. But then I thought, well, maybe you think I'm pulling your legs collectively, because what, as Bert said, is a professor of cancer prevention talking about dementia. And I thought about it a bit, and I started to worry that I was victim of a syndrome that I described several years ago called aging epidemiologist syndrome. I had noticed that as epidemiologists get older, they tend to acquire an interest in the epidemiology of dementia that they may not have had from the start of their careers, unlike Bert and Deborah Blacker, who've been doing this all along. And so then I thought, well, is there any data to back this up? And so I went to PubMed, and I put in some famous names, and then I went to their Wikipedia pages. So I went to PubMed, and I searched their name and the word dementia, and found the first publication. And then I went to their Wikipedia pages and discovered their date of birth, and calculated that, yes, this does seem to be a definite phenomenon. Michael Marmot perhaps was a spring chicken at the age of 63. But of course, you can sort of see how this happens, right? Basically, we've been doing Walter's nutritional epi, Frank is environmental epi, respiratory, Michael is social epi, the late Valerie Beryl, cancer epi, Richard Dole, everything epi. And then you start to get a little worried. You can't quite get the next word in the sentence, and you can't remember somebody's name. And where did I put my keys? And so you start to feel the hot breath of cognitive decline and think, well, maybe I should start studying this to see if I can do something about it. So that was my prevailing theory. But actually, being trained in this department, of course, I was well trained in trying to think about alternative causal explanations. And so it occurred to me, well, maybe this is not a phenomenon of the aging epidemiologists, but it's a phenomenon of their aging cohort studies. So I sort of got the cohort start date for Nurses 2, Nurses 1, Whitehall, Million Women study, British Doctor study, and looked at the latency between the start of the study and the first publication on dementia for these people. And sure enough, if you enroll people in relatively early life or midlife, dementia, as we all know, being a sort of very late life, ideally, diagnosis, it takes a long time before the data's mature and you have a power to look at anything to do with dementia. So you can decide, is it the epidemiologist or is it the data they have at their fingertips? And you can also decide at the end of the talk whether a cancer epidemiologist has any business venturing coals to Newcastle in Bert and Deborah and other people's domain. So the real reason that I got into this was the other thing that happens in your career, which is that you have junior colleagues who have interests. And so in my case, Iris Kim was a Harvard-Oxford Program Epidemiology Fellow. She'd done neurology work here. She came to work at Oxford. Neo Tapella got her MD from Harvard Medical School. She was interested in hypertension. Tianxin Ye was a postdoctoral fellow here, also doing some neuro work in nutrition. Tom Littlejohns came about 5 years ago, I think, as a senior epidemiologist, and his doctoral degree and early work was on cognitive function and dementia. So I'm basically just following them. And pretty much all the work I will present has been done by these and other people. So I'm going to discuss something that was a little earlier on in my career about hypertension, ApoE, and cognitive function decline, kidney function and dementia, infectious diseases and dementia, neuroticism and dementia and brain structure, and biomarkers of dementia risk. Now, the Lancet Commission, I don't know if anybody here was involved in that, purported to sort of survey the literature and tell us what the factors linked to dementia risk are. And even at sort of quite minute detail, will first of all tell us are these early life factors, midlife factors, late life factors, and what percentage was the attributable risk for dementia. So you'll see these things here. You may notice that there's sort of no diet if you don't count excessive alcohol as diet, and there'd be people at the school who might think that that's an unfortunate omission. But this is basically what we know about dementia in terms of risk factors, and the good news is that it adds up to about, if you were in the right category of all of these things, 45% of dementia is in theory preventable. So the question is, can we add stuff? These are the 14 risk factors on the left that they came up with, and then they sort of partition them into the pathophysiology of dementia, a variety of often cardiovascular risk factors that, if you ameliorated them, would decrease vascular damage. Some factors that are specific for dementia neuropathology, some factors that might be causing some of the neuropathology to be exacerbated, so stress and inflammation. And then in early life, what's the cognitive and brain reserve that you start off with, and how do you preserve that over time? Notably, they don't mention any of the genetic risks here, presumably because they were non-modifiable and the Lancet Commission was interested in modifiable risk factors. So I'm going to actually talk about the four things at the bottom of this list are things that are not on their list of things that are associated with dementia. And you can tell me at the end of the talk whether you think any of them are. Hypertension, of course, has been known for a long time to be a risk factor, but they only give it a 2% attributable risk. Felt low to me. So I got into this actually earlier, but through a different portal. And the portal was, of course, genetic epidemiology, and ApoE4 is still the most common allele that has a risk of above, twofold associated with a common outcome. Discovered in the early 1990s, maybe the late 1980s, and white British, but European ancestry. About 1 in 5 of us carry one ApoE4 allele, which gives us about a threefold risk of dementia, and 2% are homozygous, and that's about a 7 or 8 risk of dementia, or you can think of it as earlier onset of dementia. So you might think in this day of genetics is everywhere, genetic determinism, genetics is out there in the social and clinical environment, you might think that if you had something this common, that was associated with something that was common as an outcome, and that many people fear, that we'd be telling people they're ApoE4 allele, particularly if there was something you could do about it. So very early on, all of the appropriate expert committees jumped in and said, no point in telling people they're ApoE4 allele. If they want to go and get it from 23andMe, be my guest, but there's no point doing it. And the reason there's no point doing it is we don't have a drug to give them. End of story. So we still basically don't do this routinely. You've got to work pretty hard, or you've got to pay somebody to get your ApoE4 allele. And probably if you go to your family physician, and if your family physician is following the rules, the family physician will counsel you not to do that because there's nothing you can do about it. There's no pill I can give you. So there were a few hints in the earlier literature once E4 came along that maybe that's not completely true. And this is data from a study as early as 2003 looking at blood pressure, and here partitioned into people on the left not taking antihypertensives, people on the right taking hypertensives. And you can see that with any E4 allele, you're at higher risk than if you don't carry the E4 allele. But if you have high systolic blood pressure, you're at higher risk still. And observational data, if you compare the people who are hypertensive but on a medication, their risk was lower even if they were E4 allele. Small numbers. We looked at this, or at least Jae-hee Kang and Fran Grodstein looked at this in the Nurses' Health Study, and this was our conclusion. Women with an E4 allele and cardiovascular conditions such as TIAs or untreated hypertension had worse cognition. So this is Nurses 1, where, again, there wasn't a whole lot of dementia diagnosis, also a difficult diagnosis to get hold of if you're following up Nurses' Health Study and you don't have a unified registry or even a kind of unified clinical record you can get at. So Fran Grodstein had the insight to study cognition over time using a telephone interview. And if you had an E4 allele, you were worse off in terms of your cognition than if you didn't, and you were worse off still if you had untreated hypertension. So Iris Kim, the Harvard Oxford Program in Epidemiology Fellow, took another look at this. About twice as many participants had been had the cognitive battery by that time. And this is the summary cognitive function score, TICS, telephone interview for cognitive status. And again, you can see that if you're hypertensive but E4 negative, no significant difference. If you're E4 positive, worse cognition, so the negative numbers are the worst cognition. And then if you take the women with a history of hypertension who are E4 positive and ask, are they on a drug to reduce their blood pressure, or they're not on a drug, worse cognition if you're not actually receiving the antihypertensive. Observational data. To my knowledge, nobody's done a randomized trial of antihypertensives and cognitive function change. If somebody knows of such a trial, please tell me. Tom Littlejohn's, we couldn't look at the drug angle, but looking at the UK Biobank, 200,000 dementia-free participants who are older than 60 at enrollment, followed for 15 years, 6,200 dementia diagnoses over 15 years. In blue here, this is the 12-year cumulative incidence of dementia if you were not hypertensive at baseline. And on the right here, we've got ApoE. So much higher prevalence of dementia diagnoses if you're an ApoE4 carrier. Not enough power to really distinguish the heterozygotes from the homozygotes. And for the first time, we could look at the polygenic risk score for dementia. So polygenic risk scores, as you know, come out of the genome-wide association studies. And this polygenic risk score does not include ApoE, so it doesn't include the big elephant in the room. It's all of the other loci that have now been established that have much, much, much lower risks, but cumulatively can be related to dementia risk. So as your dementia PRS goes up, your 12-year cumulative incidence of dementia goes up. But again, it goes up higher if you are hypertensive. And the relative risks, about 1.3, 1.4, are pretty similar. If you are low, medium, high, or you're a E4 carrier or not an E4 carrier. But of course that means that the risk differences are much bigger in the people who start off at higher risk. So again, if we could wave a wand and abolish hypertension, we would at least delay a lot of dementia diagnoses, and we'd delay more on the the denominator of E4 carriers than we would on the denominator of non-E4 carriers. I said that wrong. Basically, the risk difference is much higher in the E4 carriers, so it has a bigger impact in the E4 carriers, even though they're only a fifth of the population. So then the question is, well, how much hypertension is there? So this is the work of Wenyu Liu, who's a senior statistician in the group. And this is unpublished data from the Our Future Health study, which I've talked about in other talks here. We're now up to 1.8 full participants. Full participant means blood sample, questionnaire, and consent to linkage to the UK National Health Records. Obviously, most of that data is still cross-sectional because we've enrolled those 1.7 million people since 2022. You can go right now and get the data subject to a fee and subject to a approved protocol by the Access Committee for 650,000 raw genotype arrays, 500,000 imputed genotype arrays, and all of the questionnaire and self-reported data, but also the linkage to the healthcare record data. Obviously, again, most of that is prevalent disease at enrollment. But we also took, using the kind of clinical standard sphygmomanometers and 5-minute rest and both heels on the floor protocol, people's blood pressure, and took the average of 2 blood pressures, and there's a lot of hypertension. These are proportions of the entire population. Hypertension goes up with age, no surprise. More hypertension among men than women, no surprise. This far right-hand bar is the age standardized prevalence, standardized to the age distribution of the UK population. And blue is people who did not know they were hypertensive at the time they had their blood pressure taken. Light blue are people who were actually on antihypertensive, but at the time they had their blood pressure taken were still above the WHO definition of hypertension, which is 140 on 90. And then successfully controlled in gray here. So this is no surprise. There's a lot of undiagnosed hypertension, or people who are at least unaware of their diagnosis. I'm continuing to be a little surprised that the number of people who are treated but inadequately treated is so high. but my GP colleagues in the UK say they're not surprised. They don't have time to be bringing people in and getting their blood pressure taken. In the UK, there's no such thing as the annual well health check. There's a system where every 5 years you can get a health check, but not everybody does that. And so one of the GPs described this phenomenon to me as fire and forget. And the same thing applied to lipids. There's a lot of people on a statin whose LDL level is still in the treatable range. Fire and forget, basically, okay, you've got high blood pressure, I've put you on an antihypertensive, tick, job done, don't bother me again. And there's just not much capacity to kind of titrate over time. So lots of hypertension. And where does the UK stand in terms of other countries? Well, actually, the UK is not too bad. So this is a WHO report. I don't think they coined the term of hypertension a silent killer, but that's kind of caught up in the New York Times and other places. And you can see, here's the UK, and solid lines are people unaware of their hypertension. These are the people who are inadequately treated. And this is European countries. This is Eastern Mediterranean. This is Western Pacific. And everywhere you look, there's just a vast amount of hypertension where people are unaware that they've got hypertension and undertreated hypertension. So you put all of this into a back of the envelope attributable risk, or population attributable risk for dementia, and I don't see where 2% comes from. So when I do it, just based on these prevalences and the relative risks, it seems to be much closer to 15 or 20%. And so I think this is we showed in our Future Health that even though there were small differences in the prevalence between different socioeconomic status, different education status, different ethnic status, hypertension was a problem in pretty much every segment of the population. Highly prevalent, there we go, said that. And ApoE, strong risk factor. So why wouldn't you want to know your ApoE? And then do everything you can to reduce your risk. So basically, I would call this sort of genetic nihilism. The eminent committees, I think, are just worried about getting people worried about, something that we don't have a pill for. But we have a pill for hypertension. Kidney function, again, not in the list. So UKB had measures of urinary creatinine and albumin excretion. Tianxin Ye, who I think worked with Walt and others, now in Taiwan, took a look at this with Tom Littlejohns in the UK Biobank. Same thing, 15 years, just about the same number of participants who developed dementia at the time they looked. Glomerular function measured using the serum creatinine and cystatin C. I won't show you both of them, but they both had the same answers. And the urine albumin creatinine ratio measured. You don't want a lot of albumin in your urine because that means your kidney isn't working properly. And the green, yellow, orange, and red is not something that I've chosen to put on this crosstab of GFR on the vertical and the albumin creatinine ratio on the right. So basically, this is good ACR, this is bad ACR, this is good eGFR, this is bad eGFR. So this is bad, bad. But these colors actually come from the risk categories for chronic kidney disease established by the Kidney Disease Classification Committee. So that's their colors. And what we put in here, though, are the risk factors not of chronic kidney disease, but we put in the risk factors for dementia. And so at every level, even with a good, clear urine with not much albumin, as your GFR declines, your risk of dementia increases. You can have an acceptable, just fine, normal GFR, but if you've got a lot of albumin in your urine, the risk increases a bit, and fivefold-ish if you're bad for kidney function. And this is adjusted for everything that we can adjust for in terms of known dementia risk factors. So again, maybe not too much of a surprise that people who have kidney disease are at high risk of other chronic diseases. The question is this just sort of age-related? We haven't been able to control for age, even though it's single years of age. But there's a few reasons to think that this might be causal. First of all, is it reverse causation? Well, there was no evidence over the 15-year follow-up that the relative risks were different in the 5 years of follow-up versus 10 to 15 years of follow-up. Now, that's only 15 years, but a lot of people with renal disease aren't going to make it to 15 years. And of course, at the end stage, renal failure, uremia, associated with severe cognitive impairment, delirium. If you've got endothelial dysfunction in your kidneys, how did you get there? A variety of risk factors. They may also mark just systemic dysfunction that might include brain capillaries. So these are just hypotheses. Depends on whether you think that that relative risk of 5 is potentially causal. Can we do anything about this? Well, of course we can do something about it, although the worse your kidneys are, the closer you are to dialysis and fairly extreme measures. So the dementia mavens in the room will know that for 100 years people have been wondering about is dementia could be connected to infectious diseases. And I gather Eric Topol yesterday, I wasn't at the talk, was excited about the possibility that the shingles vaccine can decrease the risk of dementia. This is all done essentially. Nobody's followed up a randomized trial of shingles vaccine for long enough to be able to get dementia as an outcome, and maybe nobody ever will. So some smart people from Stanford went around looking for data and looking for a regression discontinuity analysis where there was a change in policy, and at a certain age you become eligible for the shingles vaccine, and prior to that you're not eligible. And in a national health system like the UK, you sort of can't buy your way into earlier vaccination. You just get it when you're eligible or not. And so they looked, and I'm sure Eric yesterday showed this sort of figure, where basically the risk of dementia drops suddenly over time in people who were eligible for the shingles vaccine. One slight wrinkle is that this is the and it's sort of not there for men, but when you collapse the two, it still looks very persuasive. And there are other studies using the same design that have reached the same conclusion. And of course, the fact that if you give a shingles vaccine, basically a chickenpox vaccine, to people who've had chickenpox in the past, it doesn't necessarily mean that varicella zoster or shingles is causing the risk of dementia. It could be that you're essentially toning up the immune system in a way that has some benefit to dementia risk. Tom discovered that in the EPIC Norfolk study, part of the big Europe-wide EPIC study, so EPIC Norfolk, 25,000 women and men, aged 40 to 79, recruited in the early mid-1990s. They've had 3 rounds of follow-up. They got blood samples over time. There was attrition. But basically based in a subcohort of 9,200 that had an infectious disease serology panel run. And the panel was developed at the German Cancer Institute in Heidelberg and has essentially antibodies to detect antigens or detect antibodies for a wide range of exposures. I mean, now I come to think of it, it's got EBV. Alberto's looked at that. Now, the problem is, as the ID people in the audience know, it's a tricky thing to be talking about antibodies to, let's say, herpes simplex 1, the cold sore virus. So what does it mean that I have antibodies at my age? Could mean I've had a recent infection. It could mean I had a distant infection. That's going to depend a little bit on the titer. And then there's different antigens that, particularly for something like EBV, display at different times. Helicobacter, though, does turn out to be something that if you've been exposed at any age, you've probably got Helicobacter antibodies. So it's a fairly good sign that you've had a Helicobacter infection in the past. Now, it could have been eradicated, but if you didn't get the antibiotic treatment, and most people still haven't had that because the Helicobacter really hasn't caused them much of a problem, and you've got to take a 12-week course, then it does discriminate between people who got Helicobacter probably in early life and people who didn't. So let's look at the two hypotheses. So these two, first of all, no relation between the cold sore virus. Also in the data, they'd asked people about frequency of cold sores. No relation between frequency of cold sores and herpes viruses, obviously, as you probably all know, if you do get them in the brain, that can be pretty devastating, but fortunately it's rare. Varicella zoster, so this is the chickenpox virus, essentially, again, no association. So this is what the shingles vaccine is vaccinating against. I don't think you can interpret this. You certainly can't interpret it as evidence the shingles vaccine isn't going to protect you against dementia, because again, it might have nothing to do with suppressing your varicella zoster. It might be all about toning up your immune system. But no suggestion that recent or past varicella infection is increasing your risk. Helicobacter, robust, 1.2 to 1.5 increase in risk. So, I mean, those of you who know Helicobacter know, well, what do we know about Helicobacter? The risk factors are being older. There's a strong birth cohort effect. Helicobacter is sort of largely being eliminated in younger people. There is a nice birth cohort association in these data. Okay, so I offer you this as a piece of epidemiology. And again, if anybody knows of a Helicobacter eradication study that has followed people for long enough to see if it alters dementia risk, that would be interesting data to have. I think I settled that. Now, again, just for completeness' sake, okay, we go to the literature, and of course, there's studies on both sides. A meta-analysis of 5 cohort studies, positive Helicobacter antibodies and all-cause dementia. Framingham's null, this one's positive. There's an interesting one from the UK CPRD, Clinical Practice Research Data Link, which is a clinically apparent Helicobacter infection. So you had to basically go, say, I've got bad heartburn, get the breath test, and get diagnosed. That was positive. The big Korea National Health Insurance, they did a panel of these things, null, and on and on and on. Shoei Sugani's study in Japan, the last one here, null overall, something they call disabling dementia, positive in the lower stratum of vitamin B12 intake. And so the proposed mechanisms, the sort of obvious one is we know Helicobacter causes achlorhydria. Basically, your stomach isn't working properly and the factor that absorbs vitamin B12 isn't available. And so your vitamin B12 goes down. There is a meta-analysis that reported a positive association between plasma homocysteine and both Alzheimer's and vascular dementia, lower B12, higher homocysteine. And then people wave their hands about, well, if your stomach's inflamed, you've got cytokines running around, maybe some of those cross the blood-brain barrier. Nobody's thinking that the Helicobacter's in your brain. It's all a kind of systemic hypothesis. Dementia was on that list. Sorry, depression was on that list as a risk factor. I hadn't really heard about this until Yaqing Gao came as a student with Tom and started to look at neuroticism and dementia risk. This is Epic Norfolk, and they had administered the neuroticism 12-item questionnaire, and you go on a scale of 0, not neurotic, 12, crippled by neurosis. And I'll just show it to you, leave it there for a moment. You can get your own score. So you get one for each of these, and you add it up. And I'm deeply envious of anybody who's 0. So you do this score, you look prospectively, and essentially linear dose response, the more positive answers to the neuroticism score, the higher your risk of dementia. And when you stratify that, it's essentially the same for men and women, arguably the same across deprivation index, this is SES, and maybe a little hint of reverse causation, because at the 20 plus years the relative risk is lower than at the less than 15, but this is still 15 years of follow-up time, no association with age. She did a mediation analysis, Tyler, and so neuroticism increased, and depression, they're on a spectrum, let's say. Some of those questions we saw could have been questions about depression. Neuroticism, apparently there's robust data that more neurotic people have more heart disease or earlier heart disease and more hypertension, perhaps related to stress. So some of this is mediated by the known risk factors, but there's still a chunk that sort of hangs out there unmediated. Now, the nice thing about the UK environment is you see it here, you can possibly go over there and see if you can reproduce it. So this is the UK Biobank. Again, here's your 12-point score. Here's the risk. And again, it's pretty much linear. And in UK Biobank, there's an attempt to disaggregate Alzheimer's from vascular dementia, a bit stronger for vascular, but also present for Alzheimer's, sort of robust for all cause. The other nice thing about UK Biobank is that for 100,000 people now, they've got MRI slices all the way down. You can look in the brain, and this is the correlation of 1,747 derived variables from the complicated. This is just a small piece of the data, but this is the white matter piece. And looking at are any of them associated with neuroticism. So basically, this is positive association, this is negative. The red line is the FDR threshold for 1,747 tests. But perhaps more persuasive is that high neuroticism more likely to have white matter intensities. Now, we all know that that's not a good thing and is linked to dementia. White matter diffusivity, so I think of this as water on the brain. So you want to have low diffusivity, and so basically high on this scale is worse, and high on this scale is sort of visibly more likely if you're above the average in the neuroticism index. And then white matter intracellular volume density, so this is the volume of your neurites. So you want to be high on that. You don't want gaping spaces between your neurons. And again, you can see a shift down. So again, I won't show you the mediation analysis, but a chunk of the neurosis dementia is arguably mediated through that. Now the question is, can you do anything about it? And of course the psychiatrists will tell you that you can, talk therapy, drugs, all this sort of stuff. I should have said that this neuroticism index, at least in the psychometric literature, is fairly robust during adult life. So if you score high on neuroticism at age 20, you're probably going to score higher at age 30, 40, and 50. So it's not just I'm neurotic or anxious this week because of some immediate life event. I suspect you probably can't do much about this, but it sort of adds potentially to the causal stuff. Let me finish with maybe the most interesting. So as we all know, most of the drugs for dementia have failed, although some of them are now FDA approved. And the argument is, well, all those studies basically took people who couldn't find their keys, with mild cognitive function or advanced cognitive function, and tried to delay the slope of their cognitive function decline. And so the Hail Mary here is, well, if we could just intervene much earlier, like we do for heart disease, et cetera, we could at least delay dementia. But the problem is, if you're a healthy person, you're going to score okay on the Minnesota mental health index. It's not obvious where you are on this trajectory. Great study in New England Journal. I still couldn't quite believe it, but it was something like 20,000 people in China who had lumbar punctures every year, and their A beta 40 to 42, actually it might be 42 to 40 ratio, and p-tau were positive. And so this established, and this has been known for a while, that you can discriminate and maybe even help diagnose Alzheimer's if people have high p-tau in their CSF. But that's not much use to most of us who aren't going to line up for a lumbar puncture with our annual checkup. But this stuff leaks into the blood, and just in the last few years, there have been more studies looking at it in blood. A company called Alamar has this new LISA assay, and it's optimized. There are O-link spin-out, and it's optimized concentrations of these markers. And they've added to the most recent panel brain-derived p-tau 217. So again, we've known for some time, or at least you guys have known for some time, that p-tau 217 is a marker of risk of dementia, but this is brain-derived. I'll show you where it comes from. We looked at this in the EPIC Oxford cohort, nested case control study, 213 cases clinically diagnosed with Alzheimer's, 213 dementia-free controls over an average time from blood sample of 19 years. This is the pathophysiology. The A beta 42 causes plaques. In response to that, you start to phosphorylate your tau proteins. They then aggregate, and you get the famous fibrils. And so again, you don't want the tau in your CSF, and some of it leaks across the blood-brain barrier. The complication is that tau can also come from the peripheral nervous system and other organs, so the total tau, in theory, is only about 20% from the brain. And this new assay can distinguish on the basis of a small molecular change in the brain-derived p-tau what's brain-derived. And so let's look at the data. This is not published, not submitted. So here's the volcano plot. And here's A beta 42, and this is what you expect, because basically if you lock up all your A beta 42 in your brain, causing plaques, it doesn't leak into your bloodstream. So low A beta 42 in the bloodstream is a good thing. I should have said this is all per one standard deviation in the amount of these proteins. 130 proteins on the assay. Here's 0.05. The Bonferroni is about here. And all of the p-taus add up, but the brain-derived does a little better than the total. And if you quintileize it, top quintile versus bottom quintile, that's a risk of dementia of 10. So, you know, you don't often see 10 for quintiles. And, you know, a little more than for the total p-tau. Area under the curve, 0.80 versus 0.78. So, two things here. This is over 20 years. And I think the previous longest running prospective study was something like 12 to 15 years. So this is detectable 20 years before the diagnosis. And arguably, right p-tau a little better than the p-tau. You can go and get your p-tau measured by the local companies if you want. So this is available. The brain-derived, this is still a research assay. And the big news here is that if you're going looking for people to sign up in your 20-year prevention of dementia study with whatever perhaps drug you're offering, this would allow you to identify the people at high risk who not only would be at high risk and cut your sample size, but might be a little more motivated to take your drug. Limitations, last few slides. All the work presented observational, don't need to tell you what that means. I haven't, on the way, disaggregated vascular dementia from AD. In the records in the UK, you can do that a little bit, and there's some evidence and validation studies that it's reasonable, but it's tough. The answer is the p-tau biomarkers are going to probably solve that problem over time, but that'll take 5-10 years to get into the records. If you're antihypertensive, try to stop your kidney function declining. I'm worried about the helicobacter right now. Not sure what you can do about neuroticism. And but these blood biomarkers, I think, as you guys know, are going to revolutionize dementia epidemiology. Thanks again to the guys. I think I mentioned most of them along the way. And the other collaborators, Epic Oxford, Epic Norfolk, Cornelia Van Duyn, you know very well, who's our guru of dementia in the Nuffield Department of Population Health. Thank you.
Thank you very much, David. Well, very exciting findings, actually, in the end. Although in the beginning, you mentioned hypertension diagnoses, and I remember in the 80s, Jerry Stambler talking about 50%, 50%, 50%. Of all hypertension, 50% is diagnosed.
Yep.
Of the 50% diagnosed, 50% is treated, and of those, 50% are well treated. And in this, it's even worse
Yep.
than it was 30 years ago in the US. So I'm very surprised by that. In any case, thank you very, very much for this overview. Please, questions. And I perhaps look for a moment, because you do not know her, to Dr. Yuan Ma, who has
nice to meet you.
this in some detail. Please,
wonderful.
Yuan,
Great.
Thank you so much. Thank you so much, Dr. Alfonso, for really all the hot topics on dementia research. And this is definitely not where we have hypertension or AD, which has come a long time on this. Just kind of a question, quick question on when we think about from the prevention perspective, right? Like hypertension, vascular factors, and currently more focus on biomarkers. I wonder, clearly the prevention part we have more to do. I wonder what would be next steps for our epidemiologists to have more voice being heard by the community. Actually, the prevention part is more important. It's not any magic bullet points we're looking for at the end of the disease, but the prevention part, how we could make this kind of the communication more kind of translate to the prevention in practice, implementation side. Let's look for all the questions.
The question is, we have all these risk factors. Some of them are modifiable. How can we get that information to the community and the clinical community? I think it's a great question. As Bert just said, we're not doing much better with dementia than we did. It takes investment, and actually there's recent data to suggest that the overall picture of hypertension control was better in the UK 10 years ago than it is now. And this is because of the underinvestment in primary care. So for most of these things, it's investment in primary care, it's knowledge and education. And then you can tell me if this number's right, because I've always understood this. If we could delay the diagnosis of dementia by 5 years, we would cut dementia by almost half because people would die of their stroke, their heart disease, or hit by a bus. So a lot of this stuff may not be about preventing dementia, it's preventing basically dementia before you die of something else. And that's the optimistic point of view, that there's a lot of stuff, and it all crosses over with heart disease as well. And, you know, the vascular features bleed into the kidney function, hypertension, major cause of loss of kidney function. So it's prevention in the round. And the good news is there aren't too many things here that are dementia-specific, that we make common cause with particularly the cardiovascular community.
Deborah? Deborah, please.
So a brief statement and
Yep,
then a
sure.
question. So the genetic counselors are revisiting ApoE.
Okay.
And I happen to be on this committee, and I took notes, but I may write you for references if I can't read my handwriting, because that is a very compelling bit of information, and it's consistent with what you think. So, but my question for you is, you have that great p-tau data, p-tau, and that's also not surprising, but you have the opportunity, I think, if you have the data, to look at the time to onset by quintile, and that would be useful for a variety of things, because if it's 20 years off, your motivation to do various forms of deprivation or to take these dangerous medicines, which may eventually work, whatever, but in any case, that would be incredibly useful. Can you do that also?
Quick answer is not so much, because in EPIC Oxford, the data we have, those cases are all clustered between 15 and 25 years. Yeah. And our first case is actually at 10 years. But if you were...
Well, that's already interesting.
Yeah. In EPIC Norfolk, and Tom's got a grant in, they've got 3 blood samples. So we'll be able to look at change in p-tau and time to dementia. And also EPIC Norfolk, because it's a little more focused, is able to get a better handle on the GP records, where, you know, some of these dementia, or at least cognitive function decline diagnoses, take a while to get into the hospital records. So, but I think EPIC Norfolk's one of the very few studies with serial samples and adequate power. But that'll be a couple of years. It's got to get funded.
Tyler Vedder.
Thank you, David. Two questions. Of the risk factors, is your speculation that the antihypertensives, kidney function, and infection are all essentially mediated by cardiovascular health, neuroticism only partially? And then second, with regard to the possibility of a randomized trial of antihypertensives on cognitive decline or dementia, do you think there's any potential for secondary data analyses of existing randomized trials of antihypertensives, or are sample sizes insufficient, or is follow-up insufficient?
I see Yuan has a better opinion than I do about that. And my worry is, who's done an antihypertensive trial recently, right? I mean, all these drugs, most of them have been around. There's one new one, but for resistant hypertension. So the good news is they've got the follow-up. The bad news is they did the studies 15 or 20 years ago. Now, you might be able to go get them and link them. The answer to your other question is, I wouldn't say it's quite as simple as you laid out, but it's along those lines. That, you know, there's this cluster of cardiovascular factors, and the neuroticism isn't part of that, except the claim is that neurotic people have higher stress levels, cortisol, and other things, and, you know, the premature heart disease might mediate some of the dementia, but most of it maybe is going directly to dementia. You know, most people who are demented, well, we have to talk about strokes, but most people have Alzheimer's. I imagine haven't had a heart attack before they got the Alzheimer's. So there'd be a lot of people, but not everybody by any means.
Thank you very much.
Curious
Laura, look.
how correlated for status in the polygenic risk score? Is there any additive effect, like if you have ApoE for PRS, like it's really bad? Or
Yes, no and yes. No correlation. Bad to be both. And so it modifies the ApoE. So that Deborah's genetic counselors probably need to know that.